Our topic is rational exponents and radicals. Now, this can seem a little bit troublesome at first, but once you get the idea, it should flow. So what I want you to kind of look at is this list of numbers to start out with. And these are pretty basic numbers that you should be able to have memorized. Yes, memorized, because it will be a lot easier for you to see these in action. Because here's an example. If I told you to calculate that number, maybe you can give me a number on a calculator, but don't use a calculator. We can almost do it by hand. And what I want you to know, if you don't know anything about how to do this, that's fine, because that's what this, by the end of this video, you will know how to do this. So let's put, well, let's think about that. We'll do that later. Let's see how confident we are. So what I want us to do is, when you make a table like this, I want you to kind of look at these numbers, 0 to 4, but I don't want to throw so many numbers at you, but I want you to, I want to skip a little bit, because I don't want to spend a lot of time going through this. So 0 to 10, or 0 through 4, I'm going to skip some numbers and then go 10 to 15. So I'm skipping some numbers right there. Yes, I do know how to count. But what I want us to kind of pick up is that you have n. N is just a number. So n is just a number. So 10, 100, I can put for n. N is just a number, any number I want. But we're going to stick to positive numbers. So, squared. Well, what does that mean, squared? So these are all the n's. These are going to be these numbers, but squared. These numbers squared. So what I mean by that, what is 3? What is 3 times 3? 3 times 3 is 9. What's 4 times 4? 4 times 4 is 16. What's 10 times 10? 10 times 10 is 100. What's 11 times 11? 121. 12 times 12. 13 times 13. 14 times 14. 15 times 15. So you should be able to know up to 15. So what if I wanted to go backwards? So what if I want to go backwards? So if I wanted to go backwards, I would take the square root. I would take the square root. So going this way, you're squaring it. Going backwards, you're square rooting it. So let's go through this. This is what we call the square root. And I'm going to give you this, I'm going to give you these right here. So let's look back here. You have the name. This is called the radical. This is called, in here, this is called the radicade, or can. This is just going backwards from this. So let's do these. So, what is the square root of 0? 1. Oh, sorry, 0. Got ahead of myself. What's the square root of 1? 1. What's the square root of 4? 2. What's the square root of 9? 3. You see this? What's the square root of 16? 4. What's the square root of 100? 10. You see the pattern? If you don't see the pattern, I'm not going to do all of them, but you see the pattern? Take the square root of these numbers. Take the square of these numbers, you get back the original number. Okay, what's the square root of 121? What is the square root of 121? 11, right? Because 11 times 11 is 121. You see, you're kind of going backwards, forwards, backwards. However, these numbers here are nice, perfect numbers. These numbers here are nice, perfect numbers when you take the square root. What happens if they're not? So what happens if they're not? There's a way we can do this, and this is what I want us to do today. So, over here, I would like us to do some examples. Example 1. What is the square root of 0? Square root of 0 is 0. Good. 2. Square root of 1. Square root of 1 is 1. What's the square root of 196? What's the square root of 196? What's the square root of 196? 14. What's the square root of 2? Wait a second. The square root of 2. Uh-oh. It's not in here. The square root of 2 is not in here. This goes on and on forever. This is what we call an irrational number. An irrational number, remember, in our number systems, goes on and on and on and on and on. Never stops. But can we try to get an approximation, try to get close to it? And the answer is yes. So, how do we get this number? Well, first off, where does the square root of 2 fall in between? Where does the square root of 2 fall in between here? Well, let me ask you something. What's the square root of 0? 0. What's the square root of 1? 1. Okay. What's the square root of 4? What's the square root of 4? Oh, 2. So, the square root of 2 is between here and here. The square root of 2 is between this nice number and this nice number. So the square root of 1 is 1. What's the square root of 4? 2. That must mean that the square root of 2 is between 1 and 2. Where? Take a guess. Look at this 2. Is 2 closer to 1? Or is 2 closer to 4? Well, 2 is closer to 1. So, this is going to be roughly about 1.3? About 1.3. This is not a perfect number. It's not these. However, you can still calculate it using these. I want you to be very careful doing these. So let's actually do some more. What, number 5? What's this? Oh, wait a second. Negative square root of 16. We never saw negative on the outside. We never saw a negative on the outside. That's fine. Leave it. But what's the square root of 16? 4. What are you missing? The negative. There's your answer. Here's more. Same thing, right? So negative's going to be there. But what's the square root of 81? Well, it's not on the list, is it? But you should be able to pick that one up. Isn't this 9 times 9? Negative square root of 225. Negative 15. Are you starting to see it? Eight. The square root of, negative 16. Do you see the difference between those two? See the difference? One's on the outside, one's on the inside. It turns out unsolvable yet. Yet unsolvable. We can't do that one yet because we haven't had the tools that we can encounter a certain realm here. So right now, this cannot do. You know what? Cannot do yet. Can't do yet. We haven't got the tools of that yet. Okay? So this one, when you ever counted a negative under the square root, we can't do it yet. It's not in our system. It's in a different numbering system. It's a different numbering system. That will come later. So let's do a couple more. So this one, number 9, the square root of 5 squared. Well, look here. Do I see 5 squared? Do I see a 5? No. But what if I did this? What's 5 times 5? What's 5 times 5? 25? What's the square root of 25? 5. What about this one? Number 10. Wait a second. 5 times 5 is 25. Take the square root of 25, you get 5. What's the square root of 99? Well, there's no square root of 99 up here. So we would have to do our approximation? No. Because what's the square root of 99? We don't know, but it's all raised squared. Wait a second. 5 squared is 25, right? How do we go backwards? Okay. So what's the square root of 99 squared? 99. This square root and this square cancel because they're just forwards and backwards. They're canceling each other. They're canceling each other out. Look at this one. What's the square root of 64? Square root of 64 is where? Is that 8? squared. What's 8 times 8? 64. Wait a second. It's redoing, they're canceling each other out when you get to something like this. They're canceling each other out. Let's look at 12. Remember that one you couldn't do earlier? The square root of 124? It's not on the list. It's not on the list anywhere, but can I think of nicer numbers? Let's see. Can I think of nicer numbers? Well, let's see. This is the square root of, 121. And what's the next number bigger? What's the next number bigger? 144. So what's the square root of 121? 11. What's the square root of 144? 12. Is this number closer to this one, or is this number closer to this one? It's closer here. So this is going to be 11 point, maybe 2. On a calculator, you can check that out. But there's your answer. So I want you to kind of look at these, is that this list is very critical as you go on in math. And I want to show you one more problem. I lied. So, our last two. The square root of all this. That's technically what you're doing, right? All this is under there. So what's the square root of 144? 12? Do you remember this? What happens when you have a square root and a square? They cancel each other out. Isn't that the same thing? There's your answer. Look at this one. Okay. What's the square root of 169? See, 169, square root of 169 is 13, right? What's the square root of a squared? Well, it's like this one, right? It cancels it out. All right. That is something that you need to also look at. There's a lot into this. I would really take your time on this concept. And these guys here come a lot later. Again, don't forget those. Those are really nice numbers. And your calculator is actually doing this, but it gives you a little bit of a better approximation, but at the same time, you don't really need a calculator anymore to do these. Okay? So, keep practicing. I'll see you in the next video.